Ordering numbers with positive exponents.
Do you remember what piece of the pie?
I think it was exponents and polynomials.
That sounds right. Okay, so from exponents and polynomials, I'm sorry I have to sit in the corner. And it is ordering
Numbers with positive exponents.
ordering numbers with positive exponents. I've had lots of questions on this topic, so I'm glad that she asked about this one. Okay, so give me the first problem, please.
3 and to the 4th power multiplied by 3 to the 3rd power. And then 3 to the 4th power multiplied by 4 to the 3rd power.
Times.
Multiplied, yeah, by 4 to the 3rd power.
Like that?
Yes, and then 2 to the 2nd power multiplied by 5 to the 2nd power. And 2 to the 5th power. Wait a minute. Multiplied to the 2nd power.
Okay, I'll do these two first. This section to me, I think it was a little confusing. And it doesn't actually start off this complex. The problems that start off were a little bit easier. So I'm going to show you what a first problem probably looked like for this one. So the first thing you might see would look something like this. 2 to the 3rd power times 2 to the 5th power, a box, and 2 to the 8th power. Okay? So that's kind of how this section started off. And they ask you to put either greater than, less than, or equal to. Okay? Were your choices. Greater than, less than, or equal to. What they're trying to get you to do is remember the power rules, the exponent rules. If you notice on this bottom one, I'm going to work that one. If you notice that you have the bases right here are both 2. Does everybody see that? Okay, so using the product rule, it tells me that I would get a base of 2 and I would take the powers and add them together. So that would be 2 to the 8th. So what I'm really comparing is 2 to the 8th and 2 to the 8th. So the answer to this one would be equal. Okay, so using the rules. Now, then they step it up a notch. Okay, then you're going to notice they'll change the problem just a little bit. And I saw someone's question, their next question looked like this. It said 3 to the 2nd times 5 to the 2nd. And then they compared that with something. I can't remember exactly what they would compare it with. Let's say I compare it with... I think they did like 15 to the 4th. Okay, now let me change that. Let me change that to 15 to the 5th. Okay, so if you noticed on the first problem that I did, the bases were the same. See, the 2's were the same. But come over here and look at this one, and you should notice that the bases aren't the same, but what's the same on this one? The exponents. So what that says is is that I can multiply those together and raise it to that same exponent. So this would become 15 to the second. And so now I'm comparing 15 to the second and 15 to the fifth. Which one of those is bigger?
15 to the 5th.
Yes, so the symbol would be this symbol right here. Okay?
What if the numbers are different and the exponents are different?
Yes, that's the one where there is a way to work it, but I think that it's easier just to use a calculator for that one. Okay, so let's come and look at the ones that Anna had in her homework set, which are a little bit more complex. So let's look at the first one. I noticed on the first one, the bases are the same, correct? So this would become 3 to the 7th. Does everybody see how I got that? Okay, so now come over to the other side. I have 3 to the 4th times 4 to the 3rd. Nothing's the same on that one, correct? Nothing's the same. So there is a trick in order to do those, but my suggestion to you would be to actually at this point, when they're not the same, just use your calculator and multiply them out and compare them. So what you would do is you would multiply 3 to the 7th on your calculator, which means 3 times 3 times 3 times 3 times 3 times 3 times 3, and get that number. So Anna, what do you get when you multiply those all together?
So that'd be 21.
No, it's not 21. It would be 3 times 3 times 3. You have to do it 7 times. 3 times 3 times 3.
The 3 to the 7th power would be 2187.
Okay, give it to me again.
2187.
Okay. So let me double check you. So 1, 2, 3, 4, 5, 6, 7. Yep, 2187. Okay, so now I'm going to be comparing that, and over here I'm just going to multiply those out now. Okay, so 3 to the 4th is 81, and 4 to the 3rd is 64. So I'm going to multiply 64 times 81, and that is 5,184. So now you can compare those, and the 3 to the 4th times 4 to the 3rd is going to be bigger.
So you only add the exponents when the bases are the same.
And the bases are the same. And if the exponents are the same, you multiply the bases.
Oh,
Okay, so watch. Look back down here at the bottom. I know it's kind of weird, but look back down here at the bottom. On this one, notice that the bases were the same. So I kept the base and I added the exponents up. On this one, the exponents were the same. So I kept the exponent the same. You see that? And I multiplied 3 times 5. I multiplied the bases together.
What if both of them are the same?
Then that's really easy. The base would be the same, and then you just add the exponents together. The tricky ones are these right here. So that's why I think that the best method is just to use the property if you can, okay? And then if everything's different, then you just do something else. So if we look at this one right here, the second one she had, I noticed that the powers are the same. Y'all see that? So that's going to be 10 to the 2nd. Does everybody see that? Okay, then look at on the other side. What's the same on the other side? The bases are the same. So whatever's the same stays the same. So the base is the same, and I add the powers together. That's 2 to the 7th. So I'm still in it at this time. I'm going to have to multiply that out. So 10 to the 2nd is equal to 100. And 2 to the 7th is big. I don't know. 2 times 2, 3, 4, 5, 6, 7, 128. So this is 128. So this side would be bigger. You can always use your calculator. But it is nice to know some of the little properties. Okay, does anybody have anything else they would like to say?